screen and stuff. Okay, so welcome to Open Source Antibiotics Series 2, Friday, 2nd of July, 3 minutes past 2. And I'm just going to share this because it's the relevant thing. So just while we're waiting for anyone else, because I think I want Alex to kick off and just tell us a little bit about what she's been measuring for toxicity. I was hoping Lee Graves will come along today, but he can't make it. He just messaged me. So he's going to come to a future meeting. But they are they're happy to redo the experiment that we have been running with them to try and identify a mechanism of action, a target in MRSA, and to look at mammalian cells in parallel. So he's going to, I'll be in touch with them by email, and he'll come along and chat about it at a future meeting. But just to give his sort of apologies for today, he was hoping to make it but can't. And then we'll do chemistry in a minute, but given that Alex is here, we can cover tox first. That would be the best way of doing it, I think, which I'm just trying to, yeah. So Alex, if you are happy just to describe a little bit of what you've been doing, that would be absolutely awesome.
Yeah, maybe I can just share the screen with my previous sort of slide, and then I can talk over that. Yeah. So last time I participated in this meeting, sorry I don't make it every time.
It's fine.
I showed you that I looked at toxicity many different ways. So first we did the COAT protocol, which just involves a resveratrol assay and then culturing the cells for 48 hours, treatment for 24. I did exactly the same procedure using MTC as a readout, and I've discussed the differences between those two. And we also looked at 1 week protocol where we seed the cells, we allow them to grow to exponential phase, treat them, and then also allow them to recover after treatment. So from comparing all of those things, and I've done this for majority of the compounds that I've been given, not all of them yet. So what I can conclude from this is, irrespective of whether it's resveratrol or MTC, we get fairly consistent values. Definitely, the absolute values are not the same for the IC50s, but definitely the trends are the same. There are, for the 48 hours protocol, the data seems to be more variable, and there could be various reasons for that. One is the growth of the cells. Is if they are not in exponential phase, then it's more variable. So what I've been doing since then, I compared this MTT readout with the 1 week protocol with a resveratrol readout, because I had this weird value for the 48 hours when looking at the resveratrol and MTT for the 983, which is a very interesting compound for us. So yeah, comparing the readouts here for the 1 week protocol, the data is a lot more consistent. So as I said before, I would trust more this data than this one. Yeah, I'm working towards sort of filling out all of this table, and I have collected more data towards that, but yeah, I haven't been able to plot it yet, sorry. So, but the trends are the same. The IC50s are between sort of 1 and 4 microgram per mil, 1 and 4 microgram per mil, yes, yeah. So that's sort of micromolar range, like tens of micromolar.
Right. Great. Yeah. Okay. Thanks. And the aim here still is to just complete this table for publication purposes, so we have a full set of data. And if and when you've got that, we just, I mean, for the paper we need the Excel, and for the website we just need, I mean, the same thing really, but something we can put in the wiki that indicates what the values are for each compound.
Yep.
That's great. Okay, and so I mean, ultimately, so far there's no big changes observed, but so we're not being alerted to some significant difference here. We're still dealing with roughly the same figures.
Yeah, yeah. So they're more toxic than they are potent, I guess. That's a concern.
Yeah, right, yeah. We Yeah, we've got an eye on this. For the, and just to summarize a little bit about what we were talking about before we came online here, there's the possibility we might be able to do, provided we've got the resources and time, do a quick and dirty DNA binding experiment, but you might be willing to look into whether that's feasible in the short term.
Yeah.
That's great, thank you.
Yeah, sort of. So I think the two, well, I don't know how many weeks ago now, we discussed that I would look at apoptosis, but so I mean, whether that is going to tell us what the mechanism of action or not it is, then it's not a given. And so, and also it would take me quite a long time to do that. So we thought that just checking DNA binding sort of more, I guess, in silico rather than in vitro approach would be a good start, and it would be faster, and especially if you want to publish quite soon.
Yeah, my view on that is we should do the experiments at North Carolina with Lee and see what we get, and then if we get something out there that justifies more work by you to tease this out, then we should do that. But let's wait for those experiments, which are going to happen anyway, and that might help us resolve some of these things.
So what's the timeline for that?
I don't know. I was hoping Lee will be here, but hopefully, I don't know. Actually, well, that's a good question. I'm in touch with him already. I'll be in touch with him again. I was hoping he'd be here, but he couldn't make it. But hopefully weeks, not certainly not months, and probably not days, because that's a bit optimistic. But weeks.
Yeah. Okay. Cool.
Just the thing that we mentioned on the previous call as well about submitting compounds to the NCI cancer cell line. I think we should look into that, because that used to be a big deal, and I haven't submitted anything ever to that. But we should probably think about that, right? Because as Andreas mentioned on the other call, the pattern of potencies there can tell you something about mechanism, right?
Yep. Yep. Absolutely.
So if that's still operating, we might be able to do that. I mean, it's always simple for open projects to ship molecules, because our MTAs are either very short or non-existent.
Cool. I haven't personally submitted anything there.
Yeah, I think
Andreas knows more.
Yeah. Okay. Right. Okay. Good. I think my colleague Zoe Waller has, if memory serves. So I might reach out to her or Andreas and see how difficult it is. Great. All right. Thank you for that. You're welcome to stick around or go and do some research if you'd like to. Okay, I'm going to share screen again just to run through a few things. So I mean, I guess the one thing I think I really wanted to do was to run through the new ADME data, which I haven't thought about. So I wanted to do it fresh now, which came in and which has been plotted very nicely here by Dana. So we have the new data here for solubility and clearance and what have you. Okay, so lots to do here. Thanks for color coding it, because there's a lot. Wow. Dana, you've plotted this. Did you have any immediate thoughts about what this might be telling us, or trends?
Well,
gut feeling.
So I thought 974 was interesting, because obviously its ADME properties are quite good, although it's not active. And then also taking a look at 864, it's not bad. And then I forget what the OSA number is, but the para-cyano compound, I think, is fairly active. And I actually don't think that we've evaluated that one. So I think that might be a good one to take a look at in these assays. If I can coordinate with Lori and see if she has bandwidth to do another batch of these, I think we should definitely include that one.
The potency is all associated with high clearance, right?
Yeah.
Huh. That's probably telling us something, no?
Yes, well, I guess the other thing to note that I think, Anthony, you pointed out, is that most of these are the 5,5, which we've already, looked at and found that it does get metabolized on that core. So also potentially including some more of the 5,6, the fully aromatic core compounds to see if that trend holds. I mean, so we've got like 978, 871, and then the rest of them I think have the aliphatic core, right? So
Parenthesis. All right. Okay. Because clearance of 978 in the top left there is still reasonably high without the. It's got this tolol.
There's also got a chlorine on the core too. Could be being conjugated with the glutathione or something maybe.
Right.
We usually don't have any substituents on the core on that side.
And you know what actually should do also, because we also got measured log D on these, which I actually didn't put in here, but that might be interesting to take a look at, especially in terms of looking at like 974. I think I'd be, now that I'm kind of coming back to it, very curious as to whether that's actually got a lower log D and if that's maybe contributing to its better ADME properties, if we can maybe try to incorporate that into kind of design of compounds going forward. That would be good to know. So I can update this.
You mean put it on the same diagram?
I can, yeah.
Yeah, that'd be useful. Yeah. I mean, the color coding is really handy.
I'm pretty sure I saved it. I hope I saved it.
Just on the solubility, it just doesn't look right, right? Some of these salts, is that what's going on? Because 978, 976, right? There's like 2 orders of magnitude different in solubility. And it's just, I mean, all of the ones, I wonder if some of these are salts.
It should, I don't think we've really synthesized them as salts.
I mean, wait, these were sent by us.
Yes, these are all ones that we've made at UCL.
How can it be so different?
But
I wonder if
the saturated. You're talking about 978 versus 976.
Well, just for example, all right, but I mean, okay, what's a better pair? Let me see. I'm just looking at one where you've got the aqueous solubility above, in the sort of hundreds, versus one that's like 3, and it's not that different, is it? Okay, so the two, wait, yeah, 974 and 876.
Yeah.
Also, look at the solubility difference between the sulfone and the sulfoxide on the bottom.
Well, maybe. Well, I mean,
both in the hundreds.
Yeah, I'm just thinking about ones where you got single digit versus hundreds, and you think, wait a minute.
Well, for 974 versus 876, I think actually log D would tell us something, because I wonder if that is maybe ionized at physiological pH or something, and that's helping.
Well, but so I'm just looking at some of the ones in the hundreds, and they're the ones with the kind of green clearance.
Yeah.
That's not uniform, but yeah, the log D might be relevant there then.
Yeah, I think that's maybe log D is driving some of that. Sorry, I should have put it on here.
That's all right.
It was a lot.
Yeah.
I can add it. I'll update.
Okay. Because I mean, again, there are some with nutty clearance rates, and some with amazing clearance rates, and that, I mean, that's really, yeah.
Yeah, I think the ones with really good clearance are the ones that are usually not active, sadly.
Sure. Yeah. Yeah. Interesting. Okay. Now these measurements were contributed pro bono, right?
Yes.
So if we wanted to send in some more recent actives without the 5-5 ring system, we would need again to ask for a favor.
Yes, I can check with Lori about that. I think probably they could do it, but yeah, we should ask before we just assume that that's possible. So I'll see what their bandwidth for that is.
Okay. All right, great, but very nice to have.
We also got the DNDI results back, and they were interesting too, because some of the inactive controls were actually really active against Lesh.
Did we, so I was looking for that. Sorry, did we post that? I missed it yesterday.
Yeah, it's on the DNDI issue, so you might have to scroll down. Yeah, keep going. That one, 60.
Oh, that's why, right, fine. Oh yeah, okay, great. Okay, happy to look at that too. Now, if that's useful, it's.
Yeah, I mean, so I had a little bit of a chat with Lori about this a couple of days ago. She just called me up on the phone. And yes, so she said they are interested in some of these for leash. And what their sort of plan is now is to try and put together a new target list based on this data. And then she said she'll share that with us. If there's anything we have that's similar, I told her we're happy to send to her if we have stock. And she said also if there's anything on that list that they're planning on making that we're interested in, we can tell them and they'll make a little extra and send it to us.
All right, well, great. What's good versus, L-infant?
For leash, I would say less than, I think 5 micromolar is considered good potency.
So 820 is totally inactive against MRSA, but it's got a 2.0 micromolar against T-cruzi and leash.
Well, even some of these are sub-micromolar against leash, which I think they're pretty interested in. Yeah, because you don't see that often.
It's like 300 nanomolar, look at that.
Yeah. Now, they are also showing some toxicity in these 2 cell lines, but I think the level of activity is such that they're still, compounds of interest for that.
Yeah.
Anything's better than amphotericin B and pentastam.
Dana, if you were happy to do color coding,
yes,
on this,
yeah,
could you? Because I bet there's something screaming out here where you've got little toxicity but activity.
Yeah.
So yeah, the same kind of greens and ambers and reds. That would be fantastic.
Yeah, I can do that.
Wow. And obviously, if anything in the toxicity here screams out against what we've seen so far, then we should pay attention to that too.
I'd say it's consistent.
Yeah, really?
822.
Okay.
86. No.
Yeah, I think that most of them that are showing lower tox in these assays are the ones that are not active against MRSA. If I just remember my impressions from kind of putting this together.
And again, the tox appears to be tracking with potency. Just on a very.
For MRSA, yeah, I would say so.
I mean, here too, right? So you're getting.
Yes.
Yeah. Right. Okay. All right. So, but color coding would be great. That's fantastic. All right. Great.
Yeah.
Thanks.
Yeah. And Northeasterns are interested in that, so we'll just obviously keep in touch with them about it.
Okay. All right. Great. Okay. So, I mean, those are the main things, I think. The MOA, the tox, the ADME data, and yeah, the link up with those compounds. Great. Does anyone have any chemistry updates they would like to share with everybody? There's no need to, unless you've got something you want to say, because I know that we've got things cooking at various places. Okay, I'm assuming just things are I haven't included anything new here because I think that everyone's working on things and we know what we're doing based on last time. So that's fine. Okay. Yeah.
Can you hear me? Okay.
Yeah.
I think I got the product from the reaction that I started last time I showed you a slide. So I was doing a proposed reaction for obtaining the first compound for the northwest amine substituent, and I think that I got the product, but I have to check this better. Yeah.
That
Well,
was
you're talking about this guy or this guy?
diethylamine.
This guy.
Yeah, that guy.
All right, great. Well, all right, well, there's a teaser. So once you got the NMR, we'll believe you.
Yeah, I know. Yeah, I'm waiting for the NMR. Yeah, but
All
I
right.
just wanted to.
Great.
Let
All
you
right.
know.
Well, fingers crossed.
Thanks.
That's great. Okay. All right, great. Look, I think that's pretty much everything. There's all the key things. Anyone got anything else they want to mention? I think it's all happening. All right, great. If no one's got anything else, that's great. Thanks for coming around, everybody, to our virtual meeting, and we'll keep everyone updated and see you next time.